Alright, so I have a couple of functions here. F of x equals x squared, and I need to prove if it's an even, odd, or neither based on this information. So let's do the first one. Class, for every x value, we're going to substitute in negative x. Let's do that. So I'm substituting every x value, I'm putting in negative x. So on this side, that means it's negative x times negative x, right? That's what negative x squared means. So class, what's negative times negative? Positive, and x times x is x squared, right? When you're multiplying the same base, you add the exponents. Now, f of x equals x squared. Every time you see x squared, you can write f of x. I see x squared here. What am I going to write? F of negative x equals f of x. I basically came back to my original problem. Yes? That means the answer is even. Let's show that to you graphically. F of x equals x squared, so if I just draw myself a quick coordinate plane. If I put in 0, I get 0. If I put in 1, 1 squared is 1, so 1, 1. If I put in a 2, I get 4. Negative 1, 1, negative 2, and this is what my graph looks like. Class, what's that word I use to show you about the graphs? What's the phrase? Evenly. So L and this Y. It's to show you that it's symmetrical on the y-axis. So I can take my mirror. And it's symmetrical, right? It's the folding line. Let's do g of x. G of x equals x minus 3 squared, so I'm going to do the same thing. Every x, I'm going to put in that's not going to be fun. Negative x minus 3 times 20, negative x minus 3. And then there, because I have two of those expressions, I have to use FOIL or the box. Right there. Class, negative x times negative x. And negative 3 times negative x. Here. 3x, and here. 9. So I get x squared plus 6x plus 9. Now if you expand this one up here, x minus 3 times quantity x minus 3, and you did the box, you would actually get the same idea. So our answer is going to be that's not right. Why I'm second guessing myself is I will show you. Because I want to say that it basically, if you did x minus 3 times x minus 3, you're going to get x squared minus 3x plus 9. Does that look the same as ours? X squared minus 6x plus 9. Is that the same? Do you see that? Same. Operations different. 6x plus 9. So this answer is neither. It's neither because it's not exactly the same. This one has a positive, that one has a negative. Let's graph it. Now I know it's the power of 2, so it's going to be which function family? Quadratic. It's going to be a parabola. It's going to be u. My leading coefficient, this a value is 1. That 1 is a positive or negative?
Positive.
So it's going to open up. Okay. If you need some other characteristics, you can always make a table of values. Remember, y is the same thing as f of x. Let's put in negative. Let's put in negative 3. Class, if I put in negative 3 here, negative 3 minus 3 is negative 6. Negative 6 squared is 36. So too high on my graph. Does that make sense? Let's pick negative 1. Negative 1 minus 3. Negative 4 squared. Too high on the graph, right? Let's try 3. 3 minus 3. And 0 squared is? Let's try 1. 1 minus 3. Negative 2 squared is 4. So we can graph these points. Negative 3 way up here, somewhere like way on top of my picture, right? Negative 1, 16. 4, 4, 4, 4, really high. Right 3, 0, and then 1, we'll try 1, 4. My graph's going to look something like this. Does that make sense? And here's my line of symmetry. Class, is this the y-axis? It's not the y-axis. It is symmetrical, but it's not symmetrical exactly on the y-axis. That's why it's neither. And the last problem. H of negative x, so every time algebraically, to summarize, to solve this algebraically, to determine if it's even, odd, or neither, I'm just going to put in negative x for x. Class, what's negative x squared? X squared, so my answer is 3x squared. Class, is that the original problem?
Yes.
Yes, it is. That means it's even. Do a quick graph. You'll just recognize that it's just the same thing, but it's becoming skinnier. So our graph will look something like this. But at the origin, because there is no y-intercept, there is no constant. And class, where's the line of symmetry? On the y-axis, that's why it's